Hello, everybody. So we'll continue with lesson 9.3. We're on page 375 of the third grade textbook. And our topic today is compare fractions with the same numerator. So in our last discussion, we talked about comparing fractions with the same denominator. In that situation, we had two different fractions, and there were equal parts in both fractions. So all we had to do was look at the numerator and count the number of pieces in each fraction. So like comparing 1/8 to 3/8. Well, the 1/8 only has one piece, and the 3/8 would have three. So 3/8 would be larger. So this time we're going to be comparing fractions with the same numerator, but different denominators. And so we'll have to look to see how that's helpful in comparing fractions. And so our essential question is, how can you compare fractions with the same numerator? All right. So Marcus is at Athena's cafe. He can sit at a table with 5 of his friends or at a different table with 7 of his friends. The same size spinach pie is shared equally among the people at each table. At which table should Marcus sit to get more pie? That's our question. He can sit at a table with 5 or at a table with 7. Each person is going to get the same size spinach pie. So including Marcus, how many friends will be sharing pie at each table? So 5 plus 1 would be 6 and 8. So what will you compare? We're comparing 1/6 to 1/8. All right, so model the problem. There will be 6 friends sharing pie A, or 8 friends sharing pie B. And so Marcus will either get 1/6 or 1/8 of a pie. So let's shade 1/6 to show how much he's going to get of pie A if he sat there. And then shade 1/8 of pie B. Because no matter where he sits, he's going to get one piece of pie. But in one table, he has to share with more people. Well, if the size of the pie doesn't change, doesn't that imply that the one that you're sharing with more people has to have smaller pieces? Yeah. So which piece of the pie is larger? Well, this piece is much larger. Okay, so compare 1/6 and 1/8. 1/6 is greater than 1/8. So Marcus should sit at a table with 5 friends to get more pie. Okay. So I think that's an important idea here, that the more pieces there are in the whole, the smaller the pieces are going to get. So which pie has more pieces? Pie B. The more pieces a whole is divided into, the smaller the pieces are. Which pie has fewer pieces? Pie A. And the fewer pieces a whole is divided into, the larger the pieces are. Okay, so this is a very important idea for today's lesson. That if I have the same numerator, but the denominators are different, if I want to compare them, then the one with the smaller number of equal parts is bigger. Okay. So another way we could do this, so we had circles divided into holes in the last one, but we could also use fraction strips. So let's look at it this way. On Saturday, the campers paddled 2/8 of their planned route down the river. On Sunday, they paddled 2/3 of their route down the river. On which day did the campers paddle farther? So you'll notice that it says 2/8. Okay, 2/8 of the planned trip on Saturday, 2/3 on Sunday. Which day did they paddle farther? So in a hole, okay, we know that the distance is still 1, no matter how much of the distance they traveled each day, the distance was going to be the same from start to finish. So on Saturday, they basically broke their trip into 8 equal sections, and they did 2/8 of the trip. All right, and then on the next day, they broke the trip into 3 equal parts, and it says they did 2/3 of that trip. Well, when I compare these, which one is a smaller piece? The one that had more equal sections. This one had 8 equal sections. This one only has 3 equal sections. So if you take 2 out of these 8, these 2 will be much smaller than these 2 pieces. So 2/8 is smaller than 2/3. So which one's the greater fraction? 2/3. So they travel farther on Sunday. Okay, and then we can also use reasoning. Okay, so for her class party, Felicia baked 2 trays of snacks that were the same size. So that's important. Okay, both of these trays have the same size. At the party, she had 3/4 of a carrot snack and 3/6 of this apple snack left over. Was more carrot snack or apple snack left over? Okay, so we're comparing 3/4 and 3/6. Since the numerators are the same, look at the denominators to compare the size of the pieces. Again, the more pieces a whole is divided into, the smaller the pieces are. The fewer pieces a whole is divided into, the larger the pieces are. So in our situation here, the 4th size pieces are going to be larger than the 6th size pieces. So now 1/4 is what then 1/6? If we just looked at one of those 4 pieces and one of those 6 pieces, 1/4 is greater than 1/6 because there are fewer equal pieces. So she has 3/4 of the carrot snack left over and 3/6 of the apple snack left over. Which one does she have more of? She has more of the carrot snack. Okay, and then they're giving an error alert that many students make is that when comparing fractions with the same numerator, be sure the symbol shows that the fraction with fewer pieces in the whole is the greater fraction. Fewer pieces, greater fraction. All right, so let's look at page 377. So they've given us two models. We have sixth size pieces and fourth size pieces. So if we just compare one piece out of both of them, we should be able to visually see that the 1/4 is larger than the 1/6. So 1/6 is less than 1/4. Again, this one has only 4 equal pieces. This one has 6 equal pieces. Well, you're going to get a bigger piece if you share with 4 people than if you share with 6 people. All right, so compare. Compare 1/8 and 1/3. Well, let's look at our fraction script for that. So that's 1/3, and that's the size, that's 1/8. So it takes 8 1/8 to equal a whole. Okay, and it's going to take 3 1/3 to equal 1 whole. Okay, so which one has smaller pieces? Well, the one with 8, right? Think of this as a candy bar. If I had a candy bar and I had to share it with 8 people, this is the size of the piece I would get. If I wanted to share it with 3 people, these would be the size of the piece. So if I wanted to be selfish, which size of the candy bar would I want to share it with? 3, right? I don't want to share it with 3 people because the pieces are bigger. All right, so 1/8 is less than 1/3. 3/4 compared to 3/8. So let's get 3/8 compared to 3/4. Oh, well, just looking at one of the fourths, 1/4 is almost the same as 3/8. So 3/4 compared to 3/8. All right. So if we drew that model, we'd have 8/8 and 4/4, and we need to shade in 3 of the 4s, and we need to shade in 3 of the 8s. Again, because they're sharing with more people, there's more equal parts in the 8s, those pieces are a lot smaller. So 3/4 is larger than 3/8. So 2/6 compared to 2/3. 2/6, 2/3. So if we use reasoning, it says that the more pieces a whole is divided into, the smaller the pieces are. So we can say the more pieces a whole is divided into, the smaller pieces are. Okay, so we could draw a circle, or we could use fraction strips, or we can use reasoning. Well, I'm going to get 2 pieces of whatever this is, right? But if I share with 6 equal parts, my pieces will be smaller than if I only shared with 3 people. So 2/6 is less than 2/3. All right, how about 4/8 compared to 4/4? Well, 4/4, that's 1 whole, right? So 4/4 compared to 4/8. No, 4/4 is a lot larger, right? And again, let's confirm that. The smaller the number of pieces, the smaller the less number of pieces in the whole, the larger those pieces are. So these 4 pieces have to be smaller than those pieces. So 4/8 is less. 3/6 compared to 3/6. It's the same thing, right? So 8/4 compared to 8/8. Okay, so 8/8 is equivalent to 1 whole. Okay, right? So 8/8 is equal to 1 whole. But then it wants us to compare that to 8/4. Well, 4/4 is 1 whole. So 8/4 would be, I'd have 2 rows of these, right? So which one has the smaller pieces, the eighths or the fourths? The eighth has the smaller pieces. So I would get more if I shared with 4 equal parts. Okay, 1/3 compared to 1/4. That's a 1/3 size piece, and that's a 4th size piece. 4 equal parts, 3 equal parts. The smaller the denominator, the larger the piece. So 1/3 is greater than 1/4. 2/3 compared to 2/6. Let's use a circle this time. So there's 2/6, and this is 2/3. So 2/6 is only about a third. So 6 pieces, 6 equal pieces, or 3 equal pieces. The larger the denominator, the smaller the pieces, right? So the 6th are a larger denominator than the 3rd, but the pieces are much smaller because there's more in the whole. So 2/3 is larger. 4/8 or 4/2. When the numerator is bigger than the denominator, that's greater than 1 whole. Okay, this is going to be less than 1 whole because there's 8 pieces in the whole, and there's only 4 of them. Okay. And again, we can always look at the size of the denominator. These pieces are a lot smaller, so I'm going to get larger pieces, 4 larger pieces than I would get here. So 4/8 is less than 4/2. 6/8, 6/6. So I have 6/8 compared to 6/6. Well, as I'm setting these down, I notice that the 6th size pieces are larger than the 8th size pieces because there are more 8ths in the whole. Okay. So 6/6 is bigger than 6/8. 1/6 compared to 1/2. Well, I'm sharing something with 6 equal parts or 2 equal parts. Look how much bigger the 2 equal parts are than the 6th size part. So there are more pieces in the 1/6 whole than there are in something that's broken into halves. 7/8, 7/8. Well, I said the same exact thing on both, so equal. All right, number 14. James ate 3/4 of his quesadilla. David ate 2/3 of his quesadilla. Both are the same size. Who ate more? Who ate more? So let's shade 3/4 and 2/3. Okay, so initially when you look at that, you're saying, well, how can I compare that? We haven't talked about different denominators, different numerators. How do I compare those? Well, we can compare what's left. So James says he knows he ate more because he looks at the amounts left. Does his answer make sense? Shade the models and explain. So basically what he's saying is 1/4 is greater than the 1/3 size piece. Is he right? Which one has a larger piece left? The 1/3. Sorry, I turned that the wrong way. 1/4 is less than 1/3, he's saying. Because he has less left. If he has a smaller piece left, he's eaten more. Okay, so that does make sense. Yeah. So when we're talking about pieces left and we're comparing to see which one was eaten more of, so think about that. Which of these was more eaten? Well, if we just compare the one piece that's left, this is a smaller piece that's left. which means more of it's been eaten. Okay, so 1/4 is less than 1/3, so he did eat more because the piece that's left is smaller. All right, 15. Quentin and Hunter are biking on trails in Katy Trail State Park. They biked 5/6 in the morning, 5/8 in the afternoon. Did they bike a greater distance in the morning or in the afternoon? What do you need to know? Five sixths in morning, 5/8 in the afternoon. The numerator is 5 in both fractions, so compare a sixth size to an eighth size and explain. 1/6 is larger than 1/8 because okay, so explain. 1/6 is larger than 1/8 because the less pieces in a whole, the larger the pieces. So how can we solve this problem? Well, 5/6 compared to 5/8. We learned 3 ways. We can use fraction strips, we could use circles, or we could use reasoning. So if we did 5/6 compared to 5/8, okay, we've already decided that the sixth size pieces are larger than the eighth size pieces. So now I'm going to put the 5/8 on top of the 5/6. All right. So when we're comparing these two circles, which one has more of the circle? The 1/6. Okay, the 5/8 covers this much of the sixths, but this piece is further. Okay, completes more of the circle. So 5/6 is larger than 5/8. So if I was using fraction strips or the circle, okay, so the eighths, 1/8, 1/8, 1/8, 1/8, 1/8. Or we have 1/6. Oops, I got off a little. Okay, so if we were using fraction strips, 5/8 compared to 5/6, there's more of the 5/6 shaded than of the 5/8. So in the morning, the boys hiked 5/6 mile. In the afternoon, they biked 5/8 of a mile. So the boys hiked a greater distance in the morning than in the afternoon. All right, 16. Zach has a piece of pie that is 1/4 of a pie. Max has a piece of pie that is half of a pie. Max's piece is smaller than Zach's piece. Explain how this could happen. Well, the only way that can happen is if the pies were not the same size. Because 1/2 is bigger than 1/4. So it would have to be something like this. So in this case, since they're not the same, we can't really compare them. Okay, so 1/4 of this will be bigger than 1/2 of this one because this pie is much smaller. So let's see. So explain how this could happen. Max's pie must be smaller than Zach's pie. All right, and 17. Before taking a hike, Kate and Dylan each ate part of the same size granola bars. Kate ate a third of her bar. Dylan ate half of his bar. Who ate more? Explain how you solved the problem. So we have two circles exactly the same size. We have one that ate half, and we have one that ate 1/3. Who ate more? Dylan ate more. And how do we know? Well, because half size pieces are larger than 1/3 size pieces. Okay, so that's it for lesson 9.3. In our next lesson, we're going to compare fractions, continue with our work on comparing fractions. So until then, may the numbers always be in your favor.